morning. In today's lecture, we will be solving two more problems on projectile motion. So, this is from your booklet, problem 3, page 21. A rescue plane drops a package of emergency rations to stranded hikers. The plane is traveling horizontally. The plane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground. So these are the two pieces of given. First, what does it mean that the plane is traveling horizontally? So you look at how the plane here is traveling. It's traveling along the x-axis. So what did we learn yesterday? If it's traveling horizontally, so this is the initial as a vector. This is the initial as a vector. So this is the initial vector. Okay. So if it's traveling horizontally, implies the initial x equal to the initial, and this is 40 meters per second, and the initial y is equal to 0. Okay? Because it's only along the x-axis, so there is nothing along the y-axis. That's the initial velocity. At a height, so these are given. What else is given? It's also given that the height from here to here is 100 meters. So from the height, what do I distract? What can I distract from the height? I distract that delta y is equal to minus 100. Okay? Because this is the height, so delta y from where it was dropped till it reached, this is delta y, it's going in the negative direction, so it's minus 100 meters. So this is a given I have in this exercise. Part A, solution, part A. Determine the horizontal range of that package. Range equal delta x equal, just repeat the lecture of yesterday. Range equal delta x. Range is from where it was dropped till it reached, but horizontally. Okay, horizontally. So it is delta x, which is equal to, according to this formula here, delta x is equal to the initial x times delta t. Okay, implies we have the initial x, but we don't have delta t. So we need to calculate delta t before we can use this equation. Notice if we try to use any other equation with delta x, here there is no 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 delta x. So none of the other formulas can allow me to get delta x. So I must choose this formula, but first I must calculate delta t. So what given do we have here? We have delta y. So where do we have delta y and delta t in the same equation? Let's look at the number 2. The initial y, I have it. Delta t, I have it. And I want to calculate, sorry, not delta t, we have it. Delta y, we have it. Delta v initial y, we have it. And what we are looking for is delta t. So we use this equation. Can we use another equation? We cannot use anything with x because this is y. Let's look at the fourth equation. We don't have the velocity at some other time, so we cannot use it. Same thing, we cannot use the last one. So we have to use equation number 2. So using equation 2, delta y equal v initial y delta t minus 5 minus 5 minus 5 delta t squared. Okay, let's solve this. Delta y is minus 100. V initial y is 0. So we drop, we remove this term. We don't have it anymore. So minus 100 is equal to minus 5 delta t squared. So minus 100 equal minus 5 delta t squared. 100 over 5 delta t squared is equal to 100 over 5, that's 20. So delta t is equal to 4.47 seconds. Okay, we got delta t, so now we can calculate range equal v initial x, which is 40, v initial x times delta t, which is equal to 40 times 4.47, and this answer is 178.8 feet. Okay, so this is how we calculate the range. Part B, let's do it here up. Change the color. Part B. What are the components of the velocity just before it hits the ground? So V final x and V final y. Okay, let's draw it first. So just before it hits the ground, it means here, just before it hits the ground, means here. Okay. Let's call this point anything, B, for example, B, and the initial point O. So at point x is equal to v y is equal to. So let's look at the third equation. This is where we have vx, it's equal v initial x. This is because acceleration doesn't change in the x direction, remember? Acceleration is downward, so only the y component changes. So this is equal to 40 meters per second, and v dy equal to, we use equation 4, it's v initial y minus 10 delta t, which is equal to v initial y 0 minus 10 times delta t 4.47, so minus 10 times 4.47, and this is equal to minus 24.7 meter per second. Part C, find the angle of, these are the components, VBX and VBY. Now it's asking me for, see the angle of impact. Here I have to remember that theta is is equal to tan inverse or shift tan on your calculator, shift tan of VBY over VX. So theta is equal to shift tangent of VBY is minus 44.7 divided by 40, and you get the answer to be minus 48.70 degrees. Make sure your calculator is in degrees. So notice here that we get VBY negative. It makes sense because look at it. Look at it. If I draw the vector here, let's put it in red. This is vector V, right? So how do I go to this vector V? I go this much along the x-axis and then this much along the y-axis. Notice that Vx is positive, it's along the x-axis, along the positive x-axis, but Vy is along the negative y-axis. So it's expected to have Vy is negative. Okay, so this is first question. You will find the full solution here. Let's do another one. It's page 4, it's problem 4, page 21. A break is thrown upward from the top of a building at an angle of 25 degrees, so as I drew here, to the horizontal, and with an initial speed of 15 meters per second. The brick is in flight for 3 seconds. So I have the angle, I have the initial speed, and I have the time. Find the x and y components of the velocity vector. So this is part A. V initial x is equal to V initial cosine theta. You should have memorized it by now. This is equal to 15 times cosine 25, and this is equal 13.6 meters per second. V initial y is equal to V initial sine theta, and this is equal to 15 sine 25, and this is equal 6.33 meter per second. Okay, that's part A. Part B, how tall is the building? How tall is the building? So he's asking about this height from here to here. He's asking about this height from here to here. So this height is what? This height is delta y. Just pay attention to the chart, to the direction. So in other words, I have to calculate delta y. Delta y, which formula allows me to do delta y, and I have the time and I have the initial y. Let's see. First one I cannot use, it solves for delta x. Second one, delta y. So delta y, which is my unknown, it's the initial y, I have it, and I have delta t. So I can use the second equation. So delta y is equal to the initial y times delta t minus 5 delta t squared. This means delta y equal the initial y 6.3 times 3 minus 5 3 squared Okay, so delta y is equal to 18.99 minus 45 delta y equal minus 26.01, so almost minus 26 meter. This is very much expected because delta y is negative, it's going in the negative direction. Implies if delta y is minus 26, implies the height of the building is equal to 26 meter. The building has or the building is 26 meter. Does it say how tall is the building? So this is the solution for this problem. And again, it's solved in the coming slide. Okay, in the next slide. That's all for today's lecture, and tomorrow we have a new one. Have a good day.